Hi, this is a recording of Machine Learning Foundations for Product Management, Module 6. So the task is to find the best model to predict net hourly electrical energy output of a combined cycle power plant using temperature, ambient temperature, relative humidity, and exhaust vacuum. So the linear regression would be the best model approach since it establishes the relationship between the features and the outcomes. Now, to determine what feature sets to use, I've calculated correlation between each of the features that we have relative to energy output. And based on those calculations, the best correlation has temperature and exhaust vacuum. It's negative, which is reversed, but nevertheless, it's better than relative humidity or energy output. So I would use those two as for the first model. And for the second model, I will use all of them. So all four of them as the features. What I'm going to do, I've used 80% of data from the file to test those models, and then remaining 20% to validate it. So I used Excel here to create regression. And as you see, this is the outcome of the regression calculations here. Um, I'm using um, R squared to determine how well the model fits data, and mean square, RMS, residual mean square as well. So the higher R squared and the lower RMS, the better model fits data. So comparing to one is temperature and vacuum, R squared 0.91, and RSM RMS is 2444. And when I'm using all of the features here, getting 0.92, which is higher than 0.91, and RMS is lower here than the model with temperature and the vacuum. So based on this, the second model is better, and that's what I will be using for to test the solution with 20% of data. And this is the output that I have. This is regression model calculations. So R squared 0.92, which is I think is better than in the test data, and RMS is 2172, which is a little bit higher than test data, but nevertheless it's still less than those with the two features. So this concludes the presentation. Thank you.